In this audio case study, we discuss a situation at a Gulf Coast chemical plant where an ethylene furnace encountered a hotspot challenge, requiring prompt action. Let's start. This case study revolves around a major chemical plant on the Gulf Coast, US, where an ethylene furnace had developed a hot spot on the shell of the radiant section of the furnace. Ethylene furnaces play a pivotal role in the production of ethylene, a crucial component in the chemical industry. The severity of the issue necessitated a prompt and effective resolution to prevent further complications of falling debris/refractory in the furnace, and around burners, along with general concerns of non-insulating surfaces reducing reliability in those areas. The ethylene furnace, known for its high temperatures, operates in the radiant section at approximately 2,150 degrees Fahrenheit or 1,176 degrees Celsius. The flue gas temperature in this area is higher, and the furnace operates under a slightly negative pressure where IGS services can still operate without having to reduce firing rate or alter normal operating radiant temperatures. The initial concern was attributed to a Z-block refractory issue, stemming from improper installation. A 12-inch by 12-inch refractory block fell from the roof into the radiant section beneath. This resulted in a hot spot on the shell of the furnace and the carburization of the steel. The internal issue could cause a cascading effect with additional reliability and efficiency concerns of refractory components continuing to fall into the radiant section of the furnace. The root cause of the concern was traced back to the improper installation of the Z-block refractory. This issue compromised the attachments that held the components together. The subsequent falling of refractory components into critical areas posed not only a process condition but also potential fouling and even fire. The plant's next scheduled turnaround was years away, and it did not want to lose production due to an emergency shutdown. The plant's engineering team invited Integrated Global Services (IGS) to repair the hot spot during the furnace's normal operation. IGS has developed a proprietary hot tech solution for online hotspot repair. The IGS team creates minimal openings to insert specially designed components and repair material, delivering a semi-permanent repair lasting at least until the next planned turnaround. The long-term implications of the intervention were not only the resolution of the immediate issue, but also the prevention of hot spots on adjacent refractory. The post-job report included comprehensive documentation, including pictures and online inspections, ensuring transparency and providing valuable insights for future maintenance.